This is the part 3 of the test 4 review. In this, we discuss graphing trigonometric functions and evaluating inverse trigonometric functions. So before we move on to the problems, let's look at the some of the basic theories. For example, let's look at the three basic graphs: sine, cosine, and tangent. So let's start with the sine graph. We know that all the trigonometric functions are periodic. So what we do is we only graph one cycle of those graphs. So let's graph the sine. Sine start with 0 and goes up to 1 and go down and goes to 0. So that is how one cycle looks like. The important values are 0 and then 180 and then 360. So 360 degrees is one period. So this is t is 360. We use t for the period, so it is 360. That's one cycle. And then important values are 1 and -1. So what you want to remember is sine start at 0. So sine 0. So that's how you remember sine 0. So sine start at 0. So sine 0. Sine start is 0. And then let's look at the cosine graph. Cosine graph is also periodic. The difference between sine and cosine is cosine start at 1 and then go down. So the cosine graph looks like this. Go down and then go up. This is also periodic. So a period is also 360. So this is one cycle. And then what happened? It's going to repeat the pattern. So we do one cycle and then just copy it again. And again, the important values are 1 and -1. So cosine is also in between 1 and -1. So this is 180. So at 180, cosine is -1. At 180, sine is 0. So those are a few important values, and also this is an important value 90. At 90, it is 0. At 270, it is 0. And sine at 90, it is 1. At 270, it is -1. Okay, so that's the basic of sine cosine. And let's look at the tangent. So tangent has this shape. But we know that the tangent is also periodic, but the period is half of the period of this one. That means it's 180. So the graph looks like this. And we know that we normally draw a tangent in a slightly different way. So so we graph tangent between 90 and -90. That's how we normally typically graph the tangent because we try to pick the symmetric part. So the graph looks like this. There's asymptote and then go to 0 and then again go to the other side of the. So that's asymptote. So this is 0. This is -90. This is +90. So at 90s, there's asymptote, vertical asymptote. So that means the function is not defined at odd multiples of 90. Okay, so the few other things that we can recall is you can see that the sine and cosine is always in between 1 and -1. The same thing happened with the cosine. Cosine is also in between 1 and -1. It's very clear from the graph. But tangent, you can see go through all the values. So tan, because the tangent theta, it is going between positive infinity and negative infinity. And then if you look at the domain of the sine cosine, and you can see the domain, we normally write the curly D is all real numbers. And the same thing with the cosine is all real numbers. Because it's periodic, it just repeat. But for tangent, and you can see there's a problem because tangent, you can see that x such that you have to remove all the odd multiples of 90, but at that point it's not defined. So this x cannot be equal to odd multiples of 90 if you try it in degrees. So it is 90 times odd multiple. How to write it? You can say 2k minus 1. So that is an odd number. So we say k is an integer. So that's how we write an odd multiple. It's not an odd multiple of 90. Can be even multiples. Okay, so those are the basics for sine, cosine, tangent. So let's look at the graphs now. So what we're gonna do is, and then also one other thing, you can see the period for tangent is 180. So it's half the sine cosine function. So the period is half the sine cosine period. Because sine cosine period is 360, tangent it is half of it. Okay, so let's look at the problems now. So what we're trying to do in this problem is graph of sine, cos, and other functions. And then we also try to find the domain and range, because you can read the domain and range easily from the graph. So that's the idea we use here. But there's an algebraic method also that we discuss later. So let's look at one by one. So first one is y equal 2 cosine 4x. So we can use the transformation method. So when you look at the transformation method, you may remember that when you multiply inside by a larger number, it's going to shrink the graph. So that means it's going to shrink 4 times in the horizontal direction, in the x direction. And then when you multiply outside by a larger number, that's going to stretch the graph. So it's going to stretch the graph 2 times vertically, shrink the graph 4 times horizontally. So that's what happened for the first one. So let's look at the first one now. So since we multiply by 4, so what happened? It is shrink 4 times horizontally. And then when you multiply outside, it happens stretch 2 times vertically. So that's what happens. So we can also use this notation for stretch. So you can say like that, and then this one you can say shrink. So you can say like that, arrow going this way, 4 times. Okay. So once you write that, it's very clear. So we're gonna go step by step. So we start with the basic graph, but we know how the basic cosine graph looks like. So that means we can start with this. So that's the basic cosine graph. So it is they start with 1, go down, and 1. So we only go with the major numbers. So it is 0, 360, and 180. So this is 1 and -1. So that's the basic cosine graph. Now what we can do, let's do the 4x first. In this one you can actually switch the two. It doesn't matter which one you do first, but there are certain steps that you need to do first. But here there's no order. So let's do the next one. So what we can do, we're gonna graph y equal cosine 4x. So what this 4 does, you're gonna shrink 4 times. That means it's gonna the whole graph gonna go between we have 0, 360. So this is 180. So you can see it's gonna shrink 4 times. That means 360 over 4, which is 90. So that means it's gonna jump to 90. So the whole graph is in between 0 and 90. The one cycle is in 0 and 90. Okay, so we can do that now. So this is between 1 and -1. So now the new graph gonna look like this. It's gonna start at 1 and then go down to -1 and then come back to 1. So that is how it looks like when you multiply by 4. That's how the 4 does. You can shrink the graph 4 times. So finally, we're gonna multiply by 2. What that does is gonna stretch vertical. But you can see the vertical size does not change, stay between 1 and -1. But now when you multiply by 2, it's gonna stretch 2 times, so go between 2 and -2. So that's what happened. So the final graph is like this. So it is 0. This is 90. And then it is 1 and 2 and -1 and -2. So this is 2 and -2. So what happens finally? So the graph gonna start at 1, go down to -1, come back and so that is how a one cycle looks like. So this is the final graph. So this is y equal to cosine 4x. Okay. And then it's also asking what is the dominant range, and it's very clear. So this is a periodic function, and we know that this is domain is all real numbers, and the range, and from the graph it is clear that the values are between -2 and 2. So that is the dominant range. So let's look at the second part. So as the next one, we have y equal 3 sine -2x plus 4. So we have four things going on here. So the first one is the number 2. That's going to shrink the graph 2 times. That's going to shrink 2 times. This is a horizontal shrink, so it's going to go like that 2 times. And then the negative sign, that's negative sign, flip the graph. So it's going to flip. So you can see the flip over the y-axis. So flip horizontally. So you can say it like that. It's going to flip horizontally. And then we have number 3. That's going to stretch the graph vertically 3 times. And then you add 4. That's going to lift the graph. That's adding 4 is the last step we do. That's the easiest one. We do that at the end. You cannot start with 4 because it's going to create a lot of problems if you start with 4. That's always the last step we do. So, and the other step actually you can even interchange because they are independent but not the last step. Okay, so let's go step by step. So we can start with the basic graph as before. So we have the sine graph. So we have y equals sine x, and this is the how the graph looks like. That's a basic graph. And then what we can do next is we can talk about 2. So we can graph y equal sine 2x. When you do that, it's going to shrink the graph 2 times. That means the whole graph now is stay between 0 and 180. So it's a one cycle, but between 0 and 180 now. So it's a graph going to look like that. It's going to shrink. So it is 1 and -1. There are no change to those numbers. And then what we can do is we can have y equal we can put the negative sign now. So since it's going to flip, so we're going to get space on this side. So this is y equal sine -2x. So we have the negative sign now. So what the negative sign does is we're going to flip this graph to the other side. So it's going to jump to the other side. So this is 360. This is -360. So this is -180. So what happened? It's going to flip the graph to the other side. So we're going to get the full cycle like this. Go up, down, up. So it's a sine graph, but it's going to go backward. Going to flip to the other side. Good. So what happened is this. Going to flip to the other side. So this is 2 sides. Okay. Now the next step is we can multiply by 3. That's the easiest step. That's a vertical shift. So we're going to do vertical shift. Vertical stretch, not the shift, vertical stretch. So that's the easy one. So we have the original graph, but so it is between 0 and 180. So what happened here is it's going to stretch 3 times. It's a 1, 2, 3. So 1, 2, 3. So it is between 3 and -3. So so we have one cycle between those two values. So we can draw this. It's going to go down and up. Ascending. Down and go up and come back to 0. Okay, these are smooth graphs, so there are no sharp corners. So that's what happened. So this is the graph of y equal 3 times sine -2x. So 2 shrink, -1 flip. and then 3 stretch. So what happened here is going to stretch 3 times, so 2 arrows, because both ways. Okay, now finally what we can do, we can lift this graph up by 4 units, so the whole graph move up. So what we normally do is we're going to see what are those n corners, because you need to move the axis now, because you can see all the numbers going to go up. So 3 going to go to 3 plus 4, 7. Negative 3 gonna go to negative 3 plus 4 means 1. So that means there's nothing on the bottom, so that means we don't leave much space on this side. And then most of the graph is above the axis, so what we do is we can have so this is 2, 4, 6, 8. So we can go numbers like that. So that means the graph is in between. So you can 0 line goes to 4. So what we normally do, we can draw this line, because that's going to help you to kind of get a good graph. And this is negative 180. So that's still sitting on this side. So that no change to that. So the graph go between a 1 and so this can start here. So go between 1 and 7. So so it is 1 and 7. 7 is here. So finally the graph now looks like this. So it's going to go down to 1 and turn, go up to 7 and come back. So that's how the final graph looks like. So what happened? So here, so this is y equal 3 sine negative 2x plus 4, and you can see what happened here is lift the whole graph 4 units. So that's what happened compared to the previous one. So that's the final graph, and then you can see from the graph is again domain is all real numbers, because this is sine cosine. So domain equal to all real numbers. The range from this one is very clear. The values are between 1 and 7. So that's how you graph the function. Okay, let's look at the next one. So we have y equal negative 2 cosine x plus pi. So this is different from previous ones because we have the x plus pi. That means when you add, it's going to move to the left side. So it's going to move pi to the left side. So pi is the half of the period, because we know that for cosine the period is 2 pi. So the half the period. That means the half the cycle move to the left. So remembering that, and we can graph this one easily. So we can start with the basic graph first. So it is periodic, go between 0 and 360, start with 1. Now what we can do is we can move the graph. So we can do the second step. We're gonna move. So we're gonna graph this one. So we're gonna graph y equal cosine x plus pi. Since we work with pi, I'm gonna change these values to radian. So we can write this one as pi and 2 pi. So it's much clearer. Okay, so what happened? You can see it's gonna move the graph to the left. Pi, that is half the graph. So that means what happened? I'm gonna move to the left. So that means now the graph gonna go between negative pi and positive pi, because it's gonna move the graph. So and then so there are no other changes. So it's gonna look like this. Start at 1, go down to negative 1 and come back to 1. That's how it looks like. Again, still between 1 and negative 1. Okay, now finally then we can do is a negative 2 cosine x plus pi. So what the negative 2 does is kind of flip vertically and also stretch 2 times. So the two things going on, flip vertically and also stretch 2 times. So that means the graph turn over and then go between 2 and negative 2. So it looks like this now. So the graph go between negative 2 and 2, and then you're going to flip over. So these are the values pi and a negative pi and pi. So since flip over, they're going to start down here and go up and then come down. So it's going to start there, go up to 0 and come back to 0. Okay, go up to 2 and come back to negative 2. So that's what happened. And finally, so that's a missing part. There was a plus 1. So that's the last part. That means we can lift the whole graph, 1 unit up. So that means so it looks like this now. So start with negative 1 now because you lift up 1, and then the line 0 now goes to 1. So that's the kind of symmetric line. We draw that as like a helping line, and then 2 and 3. So this is 3. So the whole graph is in between these two lines. So that's the final graph. So what happened is then these numbers not going to change. So it's negative pi and pi. So you can start here. So lift up 1 and then go between and then go to 0, go to 3 and come back. So the final graph start there, go through this, go to 3, come back and go to negative 1. Okay, so that is one cycle of the graph. So and then you can see again this is sine cosine, so the domain is all real numbers, and the range in this case you can see going from negative 1 to 3. From the graph it's very clear. So that's how we do it. So we just use the transformation techniques to graph the sine cosine functions. So let's look at the standard form of the sine cosine tan functions. So we look at these two equations. So we look at y equal a sine bx plus c plus d, or y equal a cosine bx plus c plus d. So this is like a what we normally call general equation. So what we do, we can transform this into this special format. So what we do, we can factor out b, but we normally use omega for that because that's what we normally use in practice. Omega is the angular frequency. So what we do, we're going to convert this problem just factoring out b. We write this one like this. So we can write this one as y equal a sine. I'm going to call this b like omega. So omega, we're going to factor out that. And then we can write this one as x minus phi plus d form. So this is what we call standard form. So what we do, we factor out and rewrite using a negative sign. And once we do problems, it will be very clear what I'm talking about here. Do the same thing with the other one also. So we're gonna factor out the constant b. Instead of b, I'm gonna write omega here. And then x minus phi. So we write with a minus sign plus d. So this is what we call the standard form. So we're gonna bring it to the standard form. So this is standard form. And once you have the standard form, so if you get a problem like that, so rewrite in the standard form first. And then what we can do, we have these results. So this omega is what we normally call in practice angular frequency. This is the angular frequency. So why we call the angular frequency? So what happens if you represent these sine and cosine as the motion of a circle? So you can see if you write them as the motion of a circle, plus means there's a particle moving on the circle. So what we do, we pick a general point, let's say general point, and then so that is the omega. So it's going to go in a circle with angular frequency. So what happened if you look at the if you drop the perpendicular to the x-axis, that is the cosine. If you drop on the y-axis, that is the sine. So that's what happened. So this the cosine is coming from the x coordinate, sine is coming from the y coordinate. So that's where these two are coming from. So you just look at the projection on the x-axis and on the y-axis, then you get these two equations. The omega is coming from, that is the angular frequency of the point P. So we just look at the projection. So that is the connection. So that is the cosine, and this is the sine one. Okay. So let's write. We have these results. So we know that when you write it like that, the amplitude. So amplitude is given by the absolute value of a, because a can be negative, so we just take the absolute value. And the period, so period we normally write as t, which is 2 pi over omega. Again, omega can be negative, so we're gonna put a absolute value sign here just to make it positive. And then we also have a frequency, uh, because it's periodic, so there's a frequency, how many cycles per second. So it is, frequency is simply 1 over t. So once you calculate t, just write upside down, or we can also write this one as absolute value of omega over 2 pi. So that's the frequency. So it is simply a frequency 1 over t. So that's how you remember that. Okay, and then also we have the phase shift. Phase shift. So the phase shift is simply phi. Um, in this form, if you write with a negative sign, phi is the phase shift. So when the phase shift positive, it's gonna move to the right from the original position. If phi is negative, it's gonna shift to the left from the standard position. Standard position is like a regular sine cosine graphs. And then we know the domain is all real numbers, unless we need a specific part. And the range, so you can see range is, so what happened is it's going to go between a and negative a, but when we add d, you're going to lift up by d. So that means a d plus or minus a. So those are the two values that you get. So it is d minus a and d plus a. Those are the two endpoints, and then we write this as an interval. Okay, so those are the theories for sine cosine. So let's look at theories for tangent. So tangent, we have this. So we have y equal a, tangent, again as before, bx plus c plus d, and then we can write this in again in the standard form, which is a tangent. So we're gonna pull the factor or the coefficient of x, which we're gonna call it omega, in x minus 4 phi format, and then plus d. So that's how, that is the standard form once you write it like that. And again, so you can see tangent goes to infinity. So there's really no amplitude here. So but if you want to write the amplitude like before, it is infinity in this case. So what is important is the period. So period for tangent is regular one is pi, but you have to divide by omega because there are omega many cycles. And then the phase shift, if you write in this form, it is phi. The same discussion as before is positive, negative. Those things happen the same way because it's a transformation. But domain, so domain can be little complicated. So because we know that you divide, avoid dividing by 0. So that means there are asymptote at 90 degrees or pi over 2 in radian. That means what happens is whatever the argument means what you plug in here cannot be, so this cannot be equal to pi over 2 or like odd multiples of pi over 2. That's what we're going to say. So in this case, so we can say it's omega cannot be omega minus x minus phi cannot be equal to odd multiples of pi over 2. We write odd multiples like that. 2k minus 1 is an odd number, so this is an odd number. So we're going to multiply by pi over 2. So here k is an integer. So that is the algebraic version of that. And then we can solve for x. So what we do is we're going to solve for x. So once you solve for x, you can see that what you get is you're going to see that x cannot be equals to phi plus pi over 2 omega 2k minus 1. I mean, it's a little bit algebra, but that's where it simplifies. So I mean, x cannot be this value. Okay, and the range, and then you can see it's go between all the values. So it's negative infinity to positive infinity. Okay, so that's for tangent. So let's look at some of those problems now. So what we have is find the amplitude, period, and the phase shift of the following functions, and say do not graph, because if you graph it you can find it. So without graphing, that means we can use the theory and also find the domain and range. Yeah, so let's go one by one. So the first one, we have a. So we have y equal -3 sine 2x. So we can write this one in standard form. That's not that difficult. So it's -3 sine. So we can say 2, pull out that, and then x minus 0. So you can put it like that. There's no d term here. The d is simply 0. So so that means the amplitude is equal to a -3 absolute value, which is 3, and the period t, which is by theory 2 pi over omega, so which is 2 pi over 2, so which is pi. The phase shift, so the phase shift phi equals 0, and the domain, so domain is -infinity to infinity, and the range is, and you can see there's no vertical shift here, so it's just scaling. So it's go between -3 and 3, because you multiply by -3, so it go between -3 and 3. Okay, so that's for that. So let's look at the next one. So we have y equal 5 cosine 3x plus pi plus 2. So we can write this in standard form. So it is 5 cosine. We're going to pull 3 out first. That's the constant. So we're going to take it out. So it is 3. So it is x plus pi over 3 plus 2. And then we're going to rewrite this with a negative sign. So if you rewrite this as a negative sign, it's a 3. X we put minus minus, so we write it like that. So that's how we write with the negative sign. So then once you do that, this simply becomes phi, negative pi over 3. Okay, so let's look at the steps now. So it's very clear. So we can get the amplitude. Amplitude is in this case 5, so which is 5, which is positive, and the period t equal 2 pi over omega, which is 2 pi over 3, and then the phase shift phi, which is negative pi over 3. So it's a negative number, that means it's going to go to left. It's going to go to left. We don't need that, we are going to grab it, just say it. So domain, so this is a sine cosine, so it is -infinity to infinity. The range, so range, we can use the theory part. So what it says, there is a d plus or minus a. So that means what are the two numbers? So d is 2, so 2 minus 5 comma 2 plus 5. So that means this is equal to -3 to 7. So that's the range. Okay, so let's look at the next one. So next we have y equal -4 tangent 7x minus pi minus 1. So again we write in the standard form. So it is tangent, so pull 7 out, so it is x minus pi over 7 and then minus 1. So now this is in the standard form. So we can identify terms. So only thing different is from, so we know that there's no amplitude, range is all real numbers. But when you come to the period, and you can see it is not 2 pi over omega, it's pi over omega for tangent. It's half the period of the regular sine cosine. Okay, so we can write one by one. So now we can find the amplitude, but we know that the for tangent there's no real amplitude. So amplitude we can say like infinity. The period is t equal, it is pi over absolute value of omega. So it is that means pi over 7, and the phase shift is phi equal pi over 7, so which is positive. So because there's a negative sign, so that is the phase shift if you ignore the negative sign. So that means it's going to go to the right, pi over 7. Okay, and the domain, so that is the only complicated one here. So domain is what we do x such that 7x minus pi, that cannot be multiples of odd multiples of pi over 2. So we write it like that, and k is an integer. And then we solve for x, so we add pi and then divide by 7. So we can say, so that means x cannot be equals to 1 over 7th pi plus x, yeah, so this is pi plus pi over 2 2k minus 1, so k in c. So which can also be simplified to x not equal to 1 over 7, and you can see, so you add the pi means 2 times pi over 2, so you can say like this. So that means if you go with that argument, you can say this is pi over 14, so this is 4k minus 1, so you can write it like that, and then k is an integer. So that is the domain. So x such that x not equal to this. Okay, I mean it can be a little complicated. It's like a little bit algebra. So that's for the future. So you might need those kind of simplification in your other clauses. So range is going from negative infinity to infinity. Okay, so let's look at the next problem. So as the next problem, what we have is a graph a general trigonometric function. So we can graph a general function. Earlier we graphed those functions using the transformation techniques. That now we're gonna graph them using those the amplitude, phase shift, period arguments. So let's see how we can use that. So it can be like much quicker in some problems. So let's look at the first one. So we have y equal negative 2 cosine 3x plus pi plus 1. We can rewrite this using the standard forms as a negative 2 cosine 3. So you can write this as x minus pi over 3. 3 plus 1. So you can write it like that. And then we have the phase shift. So it is negative pi over 3. So let's calculate the period. So the period for this one is t equal to pi over omega, so which is 2 pi over 3. That's a period. The phase shift, so the phase shift is phi, which is negative pi over 3, so which is a negative number. That means it's going to go to the left, pi over 3. You can see pi over 3 is half the period here, where the period is 2 pi over 3. So you can see it's a half of that. That means you're going to move the half of the cycle to the left. So that's how you can remember it. And then also for this problem, and you can see range. So range is what? So it's going to go between negative 2 and 2, and then you add 1. That means the range is simply, you can see between negative 1 and 3. So those, we can use those three information to graph it quickly. So this is how we do it. So we can look at the shape first, and then we know that this is a cosine. So that means it has to be like that. So this part we know is a cosine graph. And then what's the negative 2? So that means, and then it's a negative 2. So what's the negative 2 does, you're going to flip over So it's gonna go like that. So that's the negative 2 and 2. And then we can see that the graph is, the period of this graph is, so we found that it is 2 pi over 3. That means this is just one cycle. It's one cycle, and then this is pi over 3. So what we do is we're going to move the graph to the pi over 3. And it says that the graph go between negative 3 and 3. So that means so it's going to move to pi over 3, and also, and then the graph go between negative 1 and 3. So that is negative 1 and 3. So this is the halfway line. So what happen is the graph go between negative pi over 3 and pi over 3, because you move the graph halfway to this side. So that means finally you're gonna start here, because go between negative 3 and 3. So go there and go up and go down. So that's the final graph. So next we have y equal 1/2 tangent 2x minus pi minus 2. So again we can write this in a standard form. So 1/2 tan, so pull 2 out as a factor. That means we divide everything inside by 2, and then minus 2. So we can find, so this is phi now, so which is the phase shift is pi over 2, positive pi over 2, so which is positive because there's a negative sign already. So the period is t equal pi over omega. That's what the theory says. So it is pi over omega, which is 2. So it's pi over 2. And the phi, so which is pi over 2. So that means it's going to go to the right, pi over 2. So pi over 2 is exactly the period. That means what happened, you move the whole, like one cycle directly to the right direction, because the period and the phase shift are the same. That means you're going to move whole cycle moves. So that means we can draw this, so we can have the basic graph. So this is a basic one. And we know that a period is pi over 2. So that means these numbers are pi over 4 and negative pi over 4. Why? Because this whole period is pi over 2. So and then so that's the graph. It's a tangent. So it's a shape of a tangent, looks like that. And then what's going to happen is it's going to move complete cycle to the right. So this is and then so what happened is so it's gonna move whole cycle to the so that means it's gonna go to pi over 4, and then this is pi over 2, and then this is 3 pi over 4. So that's where the new graph is. And then you can lift this up, I can go down by 2. So the negative 2 does is go down by 2. Okay, so that means we can have the final graph like that. So this is the pi over 4 line, this is pi over 2, this is 3 pi over 4 line, and then what happened is this point moved down to negative 2. So that's where the negative 2 is. So this means final graph gonna look like this, go like that, go there, and go like that. So that is the final graph. So this is at pi over 2 now. That's the negative 2. So that's the final graph, y and x. Okay, so that's about that. And then as before, so you can write the range and the domain, and you can see the range is all values. So domains so it cannot be odd multiples of pi over 4 now. So it's pi over 4 is 3 pi over 4. So the x cannot be equal to odd multiples of pi over 4. Okay, so it's 3k 2k minus 1. So 2k minus 1. So odd multiples of, not odd multiples of pi over 4. We got pi over 4, odd multiple pi over 4, you get asymptotes. Okay, so that's how the graph, and the range is all real numbers. So range is all real numbers, but the domain is there. Okay, that's the domain. X cannot be equal to this value. Okay, so that's about that. So let's look at the last problem, which is about inverse trigonometric functions. So let's look at the basics first. Inverse trigonometric function. Let's start looking at the sine inverse first. Y equals sine x. Or sometimes we also write this one as arc sine using the unit circle approach, because arc length of the unit circle is exactly equal to the sine inverse. So the graph of this one looks like this. So x and y. So you can see the domain is going from -1 to 1. The range is negative pi by 2 to pi by 2. That's how we define the sine inverse. And then here it's very clear that the x values has to be between -1 and 1, and the y value has to be between positive pi over 2 and negative pi over 2. So negative pi over 2 and positive pi over 2. And then we have these cancellation properties. So we have sine inverse sine theta equal theta if theta is in between pi over 2 and negative pi over 2 and pi over 2. And then sine inverse x gonna cancel out and get x if x is in between 1 and -1. So those are the two cancellation properties. And then so you can see for the first cancellation, theta has to be between negative pi over 2 and pi over 2. So let's look at the cosine inverse. So y equal cosine inverse, or you can say arc cosine. So this has this graph. So this is like a slightly different situation. So this is -1 and 1. So you can see it is going from 0 to pi. So that's how we define the cosine inverse. So this is the cosine inverse graph. So it's the range is from 0 to pi. So again, x has to be between 1 and -1, and it's very clear. And then the range going from 0 to pi. And then we have these cancellation properties. So cosine inverse cosine inverse cosine theta gonna cancel and get theta if theta is in between 0 and pi. So if between 0 and pi, you can cancel it. And then cosine inverse theta equal not theta, this we normally write x here because it's a number. So x equal x if x is in between -1 and 1. So those are the cancellation properties for the cosine inverse. So let's look at the cancellation properties for tangent. Y equal tan inverse x, or we also call arc tan x. So the graph looks like this. The asymptote now goes to the become horizontal now. So this is pi over 2 and negative pi over 2. And the graph gonna go like this. Good. So we have, and you can see that in this case, so x is going between infinities, and then y has to be between negative pi over 2 and positive pi over 2, not including the corners because those are asymptote. It never becomes, you never get the value. And then we have these cancellation properties. So tan inverse tan theta can be cancelled if theta is in this range pi over 2 and not including, so we don't write pi over 2, and then tan inverse cancel for any x. So this is for any x, any x. So these are the cancellation property for tangent. So let's look at some of the problems now. So we're going to find the exact value of these inverse trigonometric functions. So let's start with the first one. We have sine inverse, sine negative pi over 17. So if you get a problem like that, what we do, we check whether this is in the right domain. And we notice that it is between negative pi over 2 and um, pi over 2. So it's in there. So because of that, the cancellation property works, so you get negative pi over 17. So that's it. So it's an easy one. Let's look at the next one. We have cosine inverse, cosine negative pi over 6. And here the angle is negative pi over 6. But the problem is this the cancellation property does not work for this problem, because we know that for cosine inverse the angle has to be between 0 and pi, but that's not the case. That means so you cannot cancel. But we notice that the cosine is an even function. So that means we can ignore the negative sign, so we can write this one as cosine pi over 6. Now you can see that this angle pi over 6 is in between 0 and pi, so that means they can cancel out. So you're going to get pi over 6 instead. So you get pi over 6. And then, so let's look at the next one. We have tan inverse, tan negative pi over 6. And you can see negative pi over 6 is in between pi over 2 and positive pi over 2. So that means the cancellation property works for this problem. So this is going to be negative pi over 6. Okay, so let's go to the next one, part D. We have cosine inverse, cosine 3 pi over 4, and 3 pi over 4 is in between 0 and pi. So because of that, the cancellation property works, so it's got 3 pi over 4. So let's look at the next one. We have sine inverse, sine 2 pi over 3. So 2 pi over 3 is in the second quadrant. So, and then you can see the cancellation property does not work because it is outside of the range. So what we normally do is we use the reference angle method and then find the value first. So this value is simply, the reference angle is pi over 3. That's the reference angle. So we know that's in the second quadrant, so it's positive. So that means this is simply equal to sine pi over 3 according to the reference angle method. Now you can see that the cancellation property works because pi over 3 is in the right domain. So that means you're going to get pi over 3 as the answer. So we use the reference angle method first and get this value, and then the cancellation property gives you pi over 3. Okay, let's look at the next one. So we have tan inverse tan 3 pi over 4. 3 pi over 4 is again in the second quadrant, which is tangent and which is a negative. The reference angle is pi over 4. So we can write this one as tan inverse tan pi over 4 according to the reference angle method. And also there's a negative sign because in quadrant 2 tangent is negative. Now what we're gonna do is we're gonna pull the negative sign out because this is an odd function. So it's a negative tan inverse tan pi over 4. Now the cancellation property works because this is in the right domain. So the answer is negative pi over 4. That's one way to do it. The other way is just try to calculate the value first and then look for, so you may see that you can also do this problem as tan inverse, and you can see if you evaluate this value, you can see it is negative 1. So that means it is negative tan inverse 1, which is negative pi over 4. So that is the other way to get the answer. Okay, so let's look at the next few. So we have G, which is sine inverse negative 0.5 5, and you can see negative 5.5 is in between 1 and negative 1. So because of that, it is simply cancel out and get this answer. And the next one is cosine, the same idea. Cosine inverse negative 0.5. Again, negative 5 is in the same interval, so it's cancel out and get negative 0.5. And then next one is cosine inverse cosine 6 pi over 5. So if you look at this problem, so this is similar to what we did earlier. So the reference angle is pi over 5. So this angle is in the third quadrant, so which is negative. So we can write this one as cosine inverse. The cancellation does not work, and you can, because it's not in the right range, because it's outside of 0 to pi. So it is, and then this is negative cosine the reference angle, and then so what you can do is, and you can see that cosine inverse is not an even function. That's not even function, so you cannot cancel the negative sign here. So what we normally do is, if you get a negative value, a normal theory is that so what we're trying to do is, we can write this one as pi minus the positive value, pi minus the reference angle. So in this case, the so reference angle is pi over 4. So that means because it's a negative value, so negative value means that it should be in the second quadrant. That's the idea. So that is the angle you are talking about. So so it is pi minus the reference angle. That's the idea, and the reference angle is pi over 4. So then we can subtract it. So pi minus pi over 4, pi over 5 in this case, pi over 5. So if you subtract, you're going to get 4 pi over 5. That's strange. So 6 pi over, so cosine inverse cosine 6 pi over 5 end up with 4 pi over 5. Okay, so let's look at the last two. So we have sine cosine inverse 2/3. This is like a different type of problem. So for these type of problems, what we normally do, we're going to consider this as theta. So we're going to say theta equal cosine inverse 2/3. And then what we do, we take the cosine of both sides. So we can say cosine theta is 2/3. So now what we do is, we draw the triangle using this cosine argument. So this is the theta, this is a cosine, that means adjacent is 2, hypotenuse is 3. So then we can find the other side by the Pythagorean theorem. So it's 3 squared 9, 2 squared 4, that means square root 5 here. So what we are looking for now is sine theta. So according to this diagram, sine theta is square root 5 over 3. So it's a very simple argument. So let's look at the next one. So we have secant tan inverse negative 1/2. So again, we use a similar argument. We're going to call this theta. So we have theta equal tan inverse negative 1/2, which says that tan theta is negative 1/2. What we do, we draw the triangles. This is negative, so that means it has to be in the fourth quadrant. So that's the triangle. So that is the theta we are talking about, and it is negative. That means negative 1 goes there, 2 goes there, because opposite over adjacent. And then you can find the other side. This is square root 5. What we are looking for is secant. So what you're looking for, secant theta. According to this figure, secant theta is hypotenuse divided by the adjacent, because this is h over a. Okay, so that's the value. So the last problem, we try to do cotangent sine inverse x. So we do the same thing. We're gonna assume this is as theta. So we draw the triangle. So theta equals sine inverse. So sine theta equals x, which is x over 1. So we can draw the triangle and then get the value. So this is x over 1. So this is 1 minus x squared square root. So that means cotangent is 1 minus x squared square root over x. So that is the answer for the last problem. So this is the end of the review. Thank you.